We need to show that derivative of y with respect to x is given by cosine squared of a plus y divided by sine a whenever we have an implicit function of the form x times cosine of a plus y equals to cosine of y. So let's begin. We will consider our given implicit function, which is x times cosine of a plus y. This is equals to cosine of y. Let's label this as number 1. We'll take the derivative on both sides with respect to x. So we have derivative with respect to x of x times cosine of a plus y, which will be equals to derivative with respect to x of cosine of y. Now here we'll have to use the product rule. So we have derivative of x with respect to x. This is multiplied to cosine of a plus y plus x multiplied to derivative with respect to x of cosine of a plus y, which will be equals to derivative with respect to x of cosine of y. Now derivative of x with respect to x, that simply equals to 1. So we have 1 multiplied to cosine of a plus y plus x times, we know the derivative of the cosine function is the negative sine function. So since we have a plus y, we'll have negative of sine of a plus y. But since here we have an a plus y, we'll need to take its derivative with respect to x. So this will be equals to derivative of the cosine function, which is negative sine, but we have a y value, so we'll get y. So that means we'll also need to multiply it to derivative of y with respect to x as a consequence of the chain rule. So let's further simplify. So here we have cosine of a plus y minus x times sine of a plus y. So this is now multiplied to derivative with respect to x of a plus y. A here is a constant, so we'll only be left with derivative of y with respect to x. So let's transpose this term from the right hand side to the left hand side. So we have positive sine y times derivative of y with respect to x equals to 0. We'll transpose this to the left hand side. So we have sine y minus x times sine of a plus y whole multiplied to derivative of y with respect to x. So here we have combined the second term and the third term, and we'll be taking cosine of a plus y to the right hand side. So we have negative of cosine of a plus y. So that means derivative of y with respect to x will be equals to we have cosine of negative cosine of a plus y whole divided by sine y minus x times sine a plus y. So we'll multiply this negative in the numerator with the denominator to get cosine of a plus y. In the denominator we have x times sine a plus y minus sine y. Fine. So what we'll do, we'll multiply both numerator and the denominator with cosine of a plus y. So we do that to the denominator as well. This is going to now give us cosine squared a plus y in the numerator, and in the denominator we have x times cosine of a plus y multiplied to sine of a plus y minus sine of y times cosine of a plus y. Right. Now if we go back to our original equation number 1, so here we have x times cosine of a plus y given by cosine of y. So here we can replace this with cosine of y, such that derivative of y with respect to x will be now given by cosine squared of a plus y whole thing divided by, so this will get replaced with cosine y. So we have cosine of y multiplied to sine of a plus y minus sine of y multiplied to cosine of a plus y. Now if we consider the denominator, so here we can use the fact that whenever we have sine a times cosine of b minus cosine of a times sine of b, so this can be also expressed as sine of a minus b. Now in our case we are considering a to be equals to a plus y and b to be equals to y. So that means our denominator will become derivative of y with respect to x will be equals to cosine squared of a plus y. So our denominator will be sine of So here we have a, which is a plus y, minus b, which is simply y. So this positive y and negative y goes away, and that gives us with cosine squared a plus y divided by sine a. Now we can finally express the derivative of y with respect to x equals to cosine squared of a plus y divided by sine a. So this is what we were asked to prove. Hence we have successfully proved it.